Welcome back. As promised, I'm going to work these problems out for you. And if you have worked it out and you've got the right answer, well, guess what? You have learned the material. So, as I said, you look at the question and the given information and determine what are you given and what do you want to do. You are given the mass in grams. You're asked to calculate the number of atoms, right? So essentially, we're going to go from grams to atoms. And I'm going to redraw that conversion sequence one more time. Now, this is not how it's typically given, okay? This worked for me and my students, and so I'm sharing this with you as well. So hopefully this will work for you as well. So to go from grams, right, you need the molar mass of the substance, whatever substance you're dealing with. And then you would need the basic conversion of mole to an atom. Okay, that's how many that's how many atoms make up a mole of that substance, right? So this is the basic conversion. If you have that in mind, well, first go ahead and we're going to solve this one. So there's 2 grams of phosphorus, okay? And then, as I said, you can just put 1 because, you know, there's no information there. And our first goal is to get rid of the grams. And the molar mass of phosphorus is 31, approximately 30. When I rounded it off, it's 30.97. I just rounded to 31. Now, you can use 30.97 as it is. It will make absolutely no difference, all right? All right? So that's how many grams of phosphorus is in a mole. Let me rewrite it. Phosphorus molar mass is 31 grams over 1 mole. That's what it means. When you say 31, it means 31 grams over a mole. So I flipped it so I can cancel the grams and grams over here. All right, let's continue our conversion. All right, so we now have our answer in moles. Now we got to get rid of the moles. So you have to know what to get rid of and what you want, right? And so we want our answer to be in atoms, right? So we got to get rid of the moles. We don't want it. And we know that a mole contains that many atoms. So a mole is 6.023, 10 to the 23 atoms. And we'll solve them all in one go. All right? So that's A. We repeat the same for B and C. And sulfur, I believe, is 32 grams per mole. Okay, sulfur is 32 grams over 1 mole. Right, same deal. If you notice, it's 2 grams of sulfur over 1 because there is, again, no information available. And we have to go from grams to atoms, so we have to follow the sequence. So it's 1 mole of sulfur contains 32 grams of sulfur, and then a mole of sulfur contains 6.023 e to the 23 atoms, right? So that will also give us our answer in atoms. And what's it for aluminum? If you go to the periodic table, aluminum is 27 roughly. So it's 27 grams over 1 mole. Okay. So that means we do the same. So 2 grams of aluminum is what we are starting with. Okay. That means there's no information, so just 1. And then 1 mole contains what, 27 grams of aluminum. Okay, aluminum. And then a mole contains 6.023 e to the 23 atoms. Okay. Now let me get the colors so I can cancel them out so you can actually see. I know I'm being a little inconsistent with my colors, but I guess I'll try my best to keep them. So that's mole, canceled, we're left with atoms. You should only be left with a unit that you're going after. There cannot be anything else left in this sequence. Like you cannot have a gram left or mole left. Same, gram cancels out, mole cancels out. We're left with atoms. Gram cancels out, mole cancels out. We are left with just atoms, right? So let's get the calculator. Okay, so when you are doing the actual calculation itself, okay, you have to use the exponent option. So it'll be 2 times 6.023 exponent 23, and then you divide that by 31. So when I do that math, I get 3.88 10 to the 22 atoms. Okay, again, I'm not writing all the numbers from my calculator. 3.88, okay, e to the 22 atoms. Okay, let's do the same for the remainder of them. I would say that you wouldn't see much difference between sulfur and phosphorus because their molecular mass is only slightly different. Okay, 2 divided by 32 times 6.022 exponent 23. Okay, so that'll be 3.76, 22 atoms. That's good enough to prove my point. It's small, but you know, that's good enough for me. Okay, that works for me. So 2 divided by 27 times 6.022 e to the 23. So that's 4.46. 4.46 e to the 22 atoms. What have we just done is, if you take identical quantities of 3 elements, the amount of atoms that make up, say, if you have 2 grams of phosphorus, okay, it should contain 3.88, roughly about e to the 22 atoms. That's a lot of atoms, right? If you take 2 grams of sulfur, okay, 2 grams of sulfur would contain 3.76 e to the 22 atoms. 2 grams of aluminum would contain 4.46 e to the 22 atoms, which proves the point why the atomic mass of each element is different, because to have 31 grams, okay, you need a lot more atoms. To make up phosphorus molecular mass of 31 grams, you need a lot more atoms than to make 27 grams of aluminum. So basically, how the number of atoms, what gives you the atomic mass, okay? So I would like to bring this little visual up. Okay, this is by far my favorite definition of what a mole is, okay? There are much more technical ones than this, but to me, this seems to really capture the idea of moles, okay? Mole gives you a way of determining the ratio of number of atoms of an element or a molecule, which we would look at in the next set of videos, to the weights. That's what I meant by, if every element on that periodic table is 1 gram per mole, okay? Every element, its atomic mass or molar mass is 1 gram per mole. That means every element would have the same atomic makeup. That is, every element would contain the same number of atoms. But that's not the case. Every element has a different atomic or molar mass, which indicates that the number of atoms that's present in every element is different, right? Just like I said earlier, okay, a carbon with an atomic molar mass of 12 grams over 1 mole does not contain the same number of atoms as a nitrogen with the 14 grams of 1 mole. Okay, this has more atoms, relatively speaking, compared to carbon and nitrogen. Nitrogen has more atoms, which is why it's got more atomic mass, more atoms over carbon. Okay, so if you look at an element that's got a large atomic mass, that means it's got more atoms. Okay, so not every element contains the same number of atoms, which is our basic analogy, basic question that we started with. Does every element has the same number of atoms? The answer is no. No, not every element contains the same number of atoms. However, a mole of an element, okay, would contain, the mole is like a messenger. Okay, right here, this mole is a messenger. That is, it communicates between grams and atoms. It's a missing piece, and the mole is like a messenger that connects grams to atoms, right? Now we have looked at just single elements, right? In the next set of videos, I will show you how to calculate the number of atoms in a molecule, such as a molecule is when either a single element appears twice, like nitrogen gas, chlorine gas, fluorine gas, iodine, etc. Or it's a molecule much bigger where you have multiples of the same element, but it's also combining with other elements to make a giant molecule. We're going to determine how many atoms there is, but the sequence is still the same, but we're still going to do a couple of problems just to let you know that there is how many atoms there is, right? All right, good. So stay tuned for the reminder of the videos. So if you have got the idea of going from grams to atoms down, then you have one thing you can check on your bucket list of things to learn. All right, stay tuned for more videos. Bye-bye.